Hello everybody, this is Elton Searcy with Think Big Analytics, and today we're going to go over how our Kylo internal standard pipeline called standard ingest works exactly. And we're going to go into NiFi and go through each step so that anybody watching this video can understand and make edits to the standard ingest pipeline. Okay, so to start things off, it's important to note that standard ingest runs using two templates. One template is the pre-processing or feed template, and the second part is the reusable template called standard ingest, where when we go into reusable templates, standard ingest up here at the top has two input ports, standard in, standard cleanup. I'll explain what those are in just a moment. And when these two templates run together, Kylo is able to track that entire process, step by step. So let's go ahead and go into test 2 standard cleanup. We'll go over to restaurant inspections here. Okay, so this is what the pre-processing or feed template for standard ingest looks like. Don't let the number of processors or colors worry you. Instead, I'm just going to go ahead and only show a few of them to you at a time. So there's two ways to start off this pipeline, one of which is to query data from a database, and the other is to actually grab a file from a local file system. When we query data from a database, this load high watermark processor here will tell Kylo basically that, hey, when this feed starts, don't let another feed trigger until this feed finishes, because this will essentially go into the Kylo services and set a flag saying that this pipeline is currently executing. And the reason we do that for databases is because sometimes you might want to read the whole database and override a table every time, but sometimes you might also just want to append whatever new data came into the database to your Hive table. In that case, you need to keep track of where you left off at. You need to make sure that you don't run insert commands side by side. Basically, that's all this high watermark processor is doing. It's kicking off the job and saying that we don't want to let another job get kicked off until the watermark is released. The second processor here will go and query the RDBMS data. If it fails, then it'll release that watermark so that the pipeline can run again. If there's no data, then it'll also release the watermark so the pipeline can run again. If there is valid data in here, then we'll go on and we'll initialize our feed parameters, which when you go through the feed in the Kylo UI and instantiate a new feed, and you go through the table customization steps, all of the attributes that are set up in there and basically define the schema of your table, what validation rules, and all that stuff that you want to use. When Kylo creates the feed, it will automatically fill in all the information in this processor with all of that information from your sample file. And this is what you'll end up seeing. For our example here, we have metadata table feed field structure, and you can see that there's about 18 columns, and this is, for anyone who has been following my other videos, this is the restaurant inspection data. So we'll go ahead and hit OK. So going through the Kylo setup wizard will initialize all of these parameters. The next processors here, if you opted in to format your data to Avro, then these processors will identify that and then update a specific value based on how we process the Avro data. It's a little different here. The Avro schema gets handled a little bit differently, but by the time we get to this output port, the attributes are all where they should be. Anyway, let's go ahead and back out. That's the pre-processing template. All that template does is it will grab a file, initialize the feed parameters, and then pass those parameters in that file on to standard ingest. And now we'll go into standard ingest, where I've actually broken it out and labeled it a little bit better in this other copy that I have. So this is an input port, and when one of those feed pre-processing templates or one of those initialized feeds actually grabs a new file, initializes its parameters, and passes that on into standard ingest, we'll have a data file and a bunch of attributes. This first attribute here goes to make sure that these values are all valid. This is where we're storing our data in HDFS, where we're storing our data on the edge node, a couple other attributes. The strip header property, depending on whether or not we opted to skip header in the table setup step, this will either skip the header or not. From there, we send the original file with the non-deleted header to be archived in HDFS, and we send the rest of the file where the header has been removed onto merge content. Now, the reason we have a merge content processor here is because sometimes the pre-processing template can load batches of data where there'll be some correlation ID, and for example, we'll have 5 different flow files come through here, all with the same data source on them. So what will happen is each flow file will get stopped at merge content, and since all 5 of the different flow files are pertain to the same feed and all the headers have been removed, it's going to merge all of those files together and go ahead and process them as one single blob. Now the next processor here says update timestamp. This is a really simple processor. This is simply getting a timestamp that we're going to use as our partition key when we go and upload our data into our feed table and into our valid and invalid tables. This next processor here was created by R&D specifically for Kylo. What it does is it will go and create HDFS folders that let me restart that. It'll go into Hive and create the different Hive tables that we need for this feed. And it'll also go into HDFS and create the underlying HDFS directories. That's what HDFS folders and register tables is doing. Once it finishes both of those things, then this processor, put feed metadata, will communicate with our Kylo metadata service and actually register with the Kylo metadata service that this feed's been initialized, that it's got these different tables, and that actually populates our search box in Kylo where we specify. Let's go to when we go in through creating a data transformation feed, for example. There's a step in there where you get to have tables auto-complete when you just type out some of their names. It's pulling all those table names and everything from the Kylo metadata, which is populated by this processor. And then record initialization, it'll go and basically tell this other processor up here that it can continue on. You'll see a flow file pause right here this whole time while this is running. And when it finishes, you'll see the flow file continue on through the processor into this next queue. Now, once the base tables and HDFS directories are created, we take our current data file that we're processing, we upload it into HDFS into the same directory where we have our feed or raw table. Now, to understand just a little bit about what different tables are created here, let's open up Hive, and in here we can see that for this one feed, it's called Food Inspections Demo, we have 5 tables. We have the table that's named after the actual feed name, just core as is, and this table actually holds all of our valid core data that we can run reports on and we can actually do anything we want with. This feed table is where the raw data is first loaded into Hive. This is where we use that put HDFS processor right here. Oops. We use this upload to HDFS, put HDFS. And then the next statement here says create feed partition, where it'll actually go and say alter table category feed underscore feed. So we're editing that feed table, and we're adding a partition if it does not exist, and we're going to use that feed timestamp and the location where we uploaded our file to in the last processor. We can see here that that location is going to be the same. Ingest root category feed ts. So once our feed table is loaded, we then launch a Spark job, which will take those validator and the validation and standardization rules, and it will go and load those into a local file on the NiFi node. Then it will take those JSON field policies that it's loaded and actually pass that into a Spark job, which will go through every single row, column, and actually validate each value against the validators and standardizers that we've defined. Now, any rows that fail the validation, we put into a table called invalid, and here we have invalid right here, and we have valid, where any data that passes all of it validations is loaded. Once we have our valid and invalid data separated, we run a profiling Spark job against the valid table, and then we also go and merge the valid table along with into the core table. So we would go and select the data from this table for the partition where we just ingested our data into it, and we would insert into food demo, inspections demo table where our core data resides. And in this case, it'd be a full override because we chose to go with the sync method. So we'll actually go in and fully overwrite that table. From there, if we opted in to index our data, once the data is merged, it will go into the success route of if data is to be indexed, then prepare some attributes for indexing, and then launch a JMS job that will actually go and index the data into Elasticsearch. Now that JMS job is actually a NiFi flow in system called index text service. What this flow does is it'll actually take the data that was processed, extract it, split it, and actually load it all into Elasticsearch so that engineers can go back and query against Elasticsearch to try to find data that's similar. So once we've kicked off the index data job, the pipeline is pretty much done. So we're going to go and release our high watermark. Even if we're not using a database starting point, we're still going to release this high watermark every time. And if that fails, then this will actually route out to the failure part of the pipeline. We'll get a notification, Kylo, saying the pipeline failed. In this instance of standard ingest, I added one more processor onto here. You won't see this in normal standard ingest. It's for a specific use case within my own project. But yeah, if you have any, and then there's this bottom part, it's called cleanup. Now, when you go into Kylo and you delete a feed, what happens is Kylo will actually go into the pre-processing part of the feed and will release a specific processor that says trigger cleanup. Right now it's disabled, but Kylo will go and actually enable this feed for a minute, and then trigger cleanup will go initialize some cleanup parameters, the same as initialize feed parameters, and then it will route to standard cleanup, which if we look in reusable templates, standard cleanup is right here, and it goes into standard ingest. So now we can see that standard cleanup is actually another input port down here that says, okay, update some attributes, drop our tables, and delete our HDFS folders for this feed. And that only happens when you delete a feed from Kylo, or using the Kylo UI. That pretty much covers standard ingest. If you have any other questions, please post them below. But until next time, I hope you the best of luck with your pipelines, and I'll talk to you later. Thanks.